Yesterday we were talking about different methods of graphical projections. We had talked about linear projections and perspectives, and we went into the details of how perspectives function, and what is the method to draw all these types of projections and perspectives. And we had taken a lot of questions also. Today we're going to move further with this, and we're going to be talking about the parallel projections, as we call them. So the parallel projections are basically two ways. They're done two ways: orthographic projections and oblique projections. There are different ways to depict a particular view, and perspective is one such view where you are having a direct correspondence to the human eye, how it is visible to the human eye. But when we talk about parallel projections, there's a slight difference in that. There are certain assumptions that we take before we draw these methods. And when we talk about orthographic projections more specifically, so it is basically how an object exists in reality. So that is the major consideration that is taken in these views. So as the word suggests, parallel projections. So parallel is nothing but something that is obviously not going to meet. Like we had discussed about vanishing point yesterday, and we had discussed about all those orthogonal lines. So orthogonal lines will be here, but they will not be meeting. So that is why it is different from the perspectives. Has anybody done anything like this in your architecture, especially the oblique projections? Just tell me in the chat box if you have done this, or if you have not done this, or if you're not aware about it, so that I could just take it into that much detail. If you are having good amount of idea, then we would focus more on the questions. Otherwise we would spend a good amount of time for the parallel projections theory part also. So just let me know in the chat box. Ritu, B7 and B3. Okay, so B3 you have done this, right? So I think you have a fair amount of idea how this thing functions. What about B7? You have done this. Okay, okay. So we would take more questions then, and we would obviously talk about the theoretical aspects also, and we would do the bare minimum. And but then I think we will just discuss about things which are very important. Okay, so everybody has done this, so that's a good thing. So there's an image on your screens. Can you see that? So this is basically your parallel projection in a nutshell. This is the most important image that actually is there for you to understand how parallel projections function. Once you are thorough with this thing, I don't think there's any trouble in understanding anything. So it is basically showing a projection of a line, right? And when we talk about projections of various objects and different 3D solids, that is important. But again, to understand this, we will be starting off from the basics. We are talking about the projection of a line. So there are two lines that are there that are shown in this particular image. So if you see how the projection is happening, I think it is very easy to understand, since you have told me that you are aware of this thing. So there are these 2 points which are there, right, on each side. So these 2 points are projected on this particular plane. Like again, you had your picture plane in the perspectives yesterday. So again, this is an image plane or picture plane as we call it. What happens is we basically are taking a photograph. So it is very similar to the principle of photography, where you have a image sensor that is there, and you have that image when you click the shutter, so that image gets imprinted. And in the earlier times we used to have those negatives that were there, and from that photographs were developed. But here it is obviously it is an imaginary plane, and we are assuming that so the observer is on this side and he's observing these particular lines, and how it is happening. So I think it is quite understandable. If anybody is having trouble in understanding this, could you please tell me? Or if it is clear, then just tell me yes sir, it is clear. So when we talk about parallel projections, So parallel projection is basically a projection of the object in a three-dimensional space onto a fixed plane, which is usually known as projection plane or image plane. Where the rays which are there, they are usually called as, so these images, because now we're going to move towards the terminologies, because that becomes very important for us to understand. So this is your line of sight. So these are your line of sight, right? So these lines are very important for you to understand, because how you are visualizing a particular object, that will help in defining the view that you are going to obtain. So these rays are usually known as lines of sight, or sometimes they are referred to as projection lines. They are parallel to each other, and hence the name parallel projections. It is one of the most basic tool in descriptive geometry. The projections are usually called orthographic, because they are orthogonal, and they are parallel, and they're going to never meet. If the rays are perpendicular to the image plane, so that's why they are called orthographic. And if it is at an angle, or it is oblique, so hence the name oblique. Or skewed, SKEW. So you remember this also. So they're sometimes referred to as skew, right? So this is how it is. These are the basic terms that you need to remember when you are talking about this topic. Parallel projections can be seen as the limit of a perspective projection. So what you are doing is, you are having a fixed point that is called the center or the viewpoint, and as this point is moved towards infinity, so that is why the lines are not meeting. In real time scenario, there is nothing called infinity, right? So you have a line of sight, and there are two lines that are converging towards a vanishing point, which always happens, like we had discussed yesterday in detail, that whether it is a road, or whether it is railway track lines. So you have a certain arrangement where there would be a vanishing point. But in this particular case, you will just have two lines of sight where they're not meeting, and they're basically parallel to each other. So a parallel projection, we can also say that it corresponds to a perspective projection, but with an infinite focal length. So because the distance between lens and focal point, as we had discussed in photography also, right? Or the application that we're using, I think is based on that particular thing. So that zoom, how much you can zoom, so that is also there. In parallel projections, lines that are parallel, they remain parallel in the 2D situation also, or as we call it as projected image. So here these are the terminologies that you need to understand, because any question could be framed out of this particular thing. When we talk about parallel projections, so there could be other ways to define this also. That basically when we are talking about these image planes like that, so two parallel line segments that are there, that you see in the image, they remain parallel when projected onto the image. So if you see, if these two lines are parallel here, that the you have basic properties for parallel lines, that the angles will be 90 degree, and the distance will not change throughout, so this whole distance is remaining the same. So here also the same thing is happening. I am hoping that you are able to see it on your screens. So this is the way it is. So this is why this parallel projection is called such. I hope you have understood this thing. When we talk about perspective projection, of an object is considered more realistic. Obviously, that is how it will look to human eye. But parallel projection has its own benefits. Obviously, when you are at site, you're not going to be, there to elaborate each and every line to the people who are going to be constructing it. So you have to have a drawing, and when you have to have a drawing, it has to be, exactly the way it is, rather than how it will be seen, because that may create confusion as well. So obviously perspective are more related to human eye and photography and the works. But again, in oblique projection or parallel projections, you get the exact view of the particular object, how that object is. So this is the basic difference. When we talk about parallel projections, they are very popular in technical applications, obviously. Why it is there? Because the direct measurements could be taken from the image. And parallel projections, if we talk about, so obviously your orthographic projections are more realistic as compared to the other methods. uh, we will be talking about a lot of things when we take up the questions, but I would just want to ask you one thing. Did you go through that video that I had mentioned, that introduction video that's there on the website? Yes or no? B3, B7 and Ritu. Otherwise I would just elaborate it quickly, because there are a few things that you need to know before we move to the details of this, because there are certain properties. Okay, you'll be watching today, Ritu. All right. Had you watched it yesterday night, it would have benefited you greatly. But anyways, I'll just okay, you have also not watched B6. What about you, B7? So I mean, you watch it today, but I'll just tell you a couple of things that are needed to understand this particular thing. So let me just stop this here and let me just do it on the whiteboard. So we had talked about different spaces and everything. So let me just draw a few things. So okay, so if I have to depict space, can I depict something like this, right? So well, let me do it with the straight line. I think that would be better. So this is a vertical plane, right? And this is your horizontal plane. So we can bifurcate, as we had already discussed. I think if you will go through the video now, you'll be able to understand how we are doing it and why we are doing it and what all science goes behind that. It is a very brief introductory video, but I think that would give you a good amount of idea. So there are a few things that I just want to tell you in this, so that you don't miss out on anything. So just see. So basically, what is happening is this particular view is your VP, as we call it. So this is your vertical plane, right? So this is your VP and this is your HP, right? This particular thing that we call it. So what happens is, this is your first quadrant, this is your second quadrant, this is your third quadrant, and this is your fourth quadrant, right? So what happens is, mostly in our drawing work and the engineers and architects, we use first and third angle projection of method. Since I mean we have been told that these are the negative quadrants, so we mostly don't use it. But there are logical reasons why we don't use it behind this particular thing. So when we talk about this particular thing, so the object mostly lies here in this particular quadrant or in this quadrant, and you have an observer that is visualizing this object in this particular direction. To see the elevation views from here, and to see the top view, you will have to see it from here. And obviously the side view will be this one, which will ultimately happen it on this particular vertical plane, so which is nothing but your auxiliary plane, right? So all this is explained in that particular video. I would suggest you to just go through that, and that would make your job very, very easy. But there are certain things that I would want to tell you before we move further. So every parallel projection, has certain properties, and the properties are, very important for you to remember, because a lot of times, questions are asked from that. So it is, usually defined by its projection plane. So these planes are there, which we, usually take as imaginary planes. And the direction is also very important, in what direction you are visualizing it. So if you have to see the front view, so you have to align yourself properly. I'm sure you have seen this kind of image earlier also, since you have told me that you have gone through all this, haven't you? B3, B7 and Ritu, you have gone through all this, right? B3, B6, B7, Ritu, just tell me, have you seen such an image that I have drawn, or no? This kind of a quadrant formation where you are bifurcating spaces into this particular manner. Yes, you have seen, all of you have seen, right? So yeah, So I think you are understanding what I'm trying to say. So let's just quickly move to the properties that are there, right? It says that the direction must not be parallel to the projection line. That is one of the major property that is there in this particular method. And when we talk about any point in the space, that is going to have a very unique image uh, in the projection plane. Uh, that is very important. The points usually are fixed. Yes, AutoCAD also has coordinates. Ritu, you're saying that. So yeah, that see all this spatial analysis and all these concepts. Obviously, since AutoCAD is just a tool for us to draw, so it will be taking certain basic parameters that are there already existing in the basic mathematics. So that is how AutoCAD was born. So yes, you are quite right, Ritu, that AutoCAD also has coordinates, and we had discussed about your UCS and WCS in the previous class. So these points are usually fixed when we talk about this parallel projection, and any line that is not parallel to the direction is mapped onto a line, and any line parallel to is mapped onto a point. So that is also very important for you to remember. Why? Because if there is an oblique situation where an object is inclined, so then you have to manage your projection lines accordingly, like it was in this particular line case, right? The image that I shown earlier. So that is there. Let me just go back to that particular image again so that you're able to understand these points better. uh, this seems very easy, again, like every other topic in this particular section. It just seems very easy, but it is not really, because when they ask you questions related to the property, things become quite complex. So just see this particular visual, and let us just understand these points. So parallel lines are mapped on parallel lines or on pair of points, just like it is happening in this particular case. The ratio of the length of two line segments on a line stays unchanged. So that ratio will be unchanged. And as a special case, midpoints are mapped on midpoints. So that is also one thing that you must remember. The length of the line segment that is parallel to the projection plane remains unchanged, and the length of any line segment that is shortened if the projection is an orthographic one. So that also sometimes is the case. Any circle that lies in a plane parallel to the projection plane is mapped onto a circle with the same radius, obviously, because it is a realistic picture of that particular object, not how it will be visualized to the human eye. So it will not become ellipse, right? Just like it happens in your isometric views or your perspectives, like we had discussed yesterday also, no, that square face may become trapezoidal, but in orthographic projections that is never the case. So any rectangle that is mapped onto a parallelogram or on a line segment is like that, right? So any figure in a plane that is parallel to the image is congruent to its image. So that is what you need to remember. And when we were discussing about cube, so in orthographic projections, the two parallel projections of a cube, you will be seeing the cases drastically different as compared to your perspective. So let us just have a look at that also. uh, I hope you have understood it till now. Have you understood it till now? Just let me know if you have any doubt. Please do ask. If it is clear to you, then we'll just move on to the next one. We will be talking about the cube now. We have discussed about the lines. Okay, Ritu, it's clear to you. Very good. B7 is also, having no doubts. Wonderful. B6 and B3. B6 is also okay with it. All right. B3, what about you? Are you there, B3? I'm not getting a response from B3. Should I move forward? Okay, B3 says yes. So, okay. So we will, move to the next bit. Okay. All right. So just see on your screens in the next slide, you have, the parallel projections for a cube. So we are, taking it a notch above now. So the parallel projection, that you see how it is happening, in this particular case, if it was a perspective, this would have, taken that vanishing point thing. But here, your cube looks exactly the way it is. So there's a different inclination that is there. So it is different to an isometric view also, So how it is shown here. So if you see these faces, these lines are same, right? Had this been perspective, this would have moved, towards a vanishing point. But here, they are all parallel, and the distance is always same. In this side also, so if it is a cube, it is a cube. It is a very basic thing, I think. But then again, these terminologies may confuse you in the examination. So just do remember that. So how the projections are happening, it is shown in the above images also. A parallel projection, it says that it corresponds to a perspective projection with a hypothetical viewpoint, one where the camera lies an infinite distance away from the object and has an infinite focal length. So this will be seen through the human eye only if your focal length is infinite, which cannot happen. Obviously our eyes don't have that kind of formation. I mean, if it was, then yes, also on 45-degree. I didn't get you, Ritu. Can you please ask it, in detail what you want to ask? Also on 45 degrees, what? Can you please elaborate, Ritu? Seems that you are saying something or you're asking something. The cube is drawn on 45 degrees. See, yeah, I mean this angle, this one, this second image you are talking about, no? This one. No. So which one? This one. First one. So this is not exactly 45 degrees. Again, 45 degrees will become an axonometric view. We will be talking about all that. But this is basically the difference in angle is there on both the sides. If you see, this angle is lesser than this angle. So it is not corresponding to your either it is 45. So that would not be a single angle, because it is inclined on one side more than the other. So it cannot be a 45 degree. 45, we will see when the oblique perspective are on 45 and 30. Okay, I think let's just hold it for a minute. I will be showing you a slide where I have made these diagrams for you, for the different viewpoints, how you're going to work about the angles, right? So let's just hold that thought for a few minutes till we discuss the basic theory behind this, so that we are thorough with this, and then I think that will give you a better understanding. Let me just discuss a couple of points in this, and then we'll move to your doubt, right? And I'll just show you that image immediately after this. Okay, so so when we are talking about this particular solid, so it stays the same because your focal length is obviously infinite. We have assumed that, and they're not going to meet. It's just like saying that you have removed the vanishing point. And once you have removed the vanishing point, so that makes your life very easy to comprehend how that particular dimension is, and how it is going to be exactly if it is under construction. So let's say you have to construct a cube. So if you give this particular drawing, everybody will be able to understand how it looks from the front, and how it is looking from the side, and how it is looking from the top, or how the 3D could be generated. So 2D to 3D, 3D to 2D, you can do it very easily. Primarily, this is how it is in the parallel projection and in the oblique projections. This is ultimately a particular view. The oblique thing that Ritu mentioned is quite correct, and oblique perspective is something else. Like you are saying, a lot of things here. Since we are moving to the image that will explain and clear your doubts. So oblique perspective is different, oblique projection is different, right? So please don't confuse the two, Ritu. Okay. Yeah. So I think you are understanding, because yesterday we had talked about angular perspective, and there were these terminologies which were there, oblique perspective and whatnot. So I think let's not confuse these terms. Let us just move to the next slide, and let us see what are the different types of views that are usually created. So yeah. Okay. So can you see there are different ways with which you draw. So the first image that is there, it is basically multi-view orthographic, right? So can you see this particular thing? I think this immediately will be able to clear all your doubts, Ritu. So I think this is what you were asking, if I'm not wrong, right? So when we are talking about the multi-view orthographic, so you have a principal coordinate plane, and then you have a single face that is exact. So this is the direction of plane. This is the exact dimension that you are achieving. To understand this particular thing. So this is the exact value that you're gonna get, and in this particular direction. So this is quite easy. This is the VP, and everything is created the way it is. I think Ritu is sorted out with her doubts. Okay, so the next one that is of importance for us is the axonometric, right? I had mentioned about the isometric view to you. I think everybody has done. So basically, it gives you three-dimensional height, width, and depth. Yes, exactly, Ritu. So it gives you, everything, every inch of the detail. So if you have two views, you can generate the third view and also the 3D, right? So you don't need that auxiliary plane much very often. But if in case the object is quite complex and you're not able to comprehend it using two views, so you use that particular third plane. So that is why it is referred to as auxiliary plane, which I had shown you. And you just go through that introductory video. I think that it is an elaborate video on this particular topic only. I don't want to repeat that whole thing. I think since you have a fair understanding and you've already gone through this, I think it must be easy for you to comprehend that. And if you have any doubts in that, you just ask me in the next class, right? So when we are talking about axonometric, so you are taking it at 45 degrees. So here it is not exact. So Ritu, what you were mentioning about it being 45 degrees, this actually is there. That whole thing is different. So is it clear to you, Ritu? So it will not be exact. And at 45 degree, you have uniformly four shortened sides, and then again it is as an angle of, as a function of angle between face normal and DOP. So that is how it is. Let's move to the third element in this particular thing. When we are talking about the oblique views, oblique projections, so what happens is you are having it as oblique, right? And in this particular case also you're going to get exact dimension. So this is the direction of the visualization, or the direction of plane, you can call it. So adjacent faces are there, one exact, others uniformly foreshortened. So I hope you have understood how foreshortening works in both perspectives and both orthogonal projections. So yes, very good. Ritu is clear with this thing. B6 and B7, are you clear with this thing? Okay, B6. What about you, B7? Okay, very good. So if you've understood this, let's move further. Okay. So should we take up a few questions now? I think that would help you learn more. Uh, or should we move to the theory? Okay, Ritu says take the question. All right. So we would move to the questions immediately. Okay. 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 So let's do the first one. The straight lines which are drawn from various points on the contour of an object to meet a plane are known as. Just message me on the chat box. Okay. Okay. So B7 and B6, both of you have answered. Ritu, can I have your answer also? We are waiting for your answer, Ritu. B7 and B6, I think you are correct. I won't, hold out the answer for you very long. Are you there, Ritu? Yes. So tell me, what should be the answer? Very good, projectors. So that is, the option B, and I think all of you are correct. Let us look at the next question. The front view of an object is shown on which plane? Profile plane, vertical plane, horizontal plane, or parallel plane? Okay. Very specific this question is. B7, you are correct. We had discussed and I had elaborated to you, that diagram just for this particular, concept. B6 and Ritu, can I have your answers also? You are also correct, B6. What about you, Ritu? Vertical plane, correct. So all of you are correct. I think you have understood this well. Okay. The top view of an object is shown on which plane? Okay. B7, you're correct. Very easy. Let's just do it quickly. So I want to take up a lot of questions today, so that we are thorough with this topic and you are, not committing any mistakes in this particular question. Okay, B7C, correct. And the two, okay. So horizontal plane is the one that is, there for your, drawing of the top view. Okay. So let's move to the next one. The side view of an object is shown on which plane? Now, they have not put in a technical term that I had mentioned to you, but you have to select the best possible, option out of this. Tell me. Confused? There are different names to that particular plane, so don't get confused. The examiner could ask you, in any different way. So tell me, B6, B7, and Ritu, what would be the plane that is there for, the side view? B. Okay. B7, you are correct. B6, you need to think it over. And Ritu, what about you? You're doing it, Ritu? You're attempting the question or still? Okay. Yes. Okay. So, you see, in this particular, projection method, the profile plane is also referred to as the plane which is directly, in front of the observer, right? So when you don't have any, plane that is corresponding to these vertical or horizontal planes, because vertical is used for your, yeah, it is actually auxiliary plane. But again, in this particular thing, it is mentioned to as profile plane. B7, you're correct. And it is, referred to as profile plane also, because PP, how it was drawn in that first image. So yes, they have taken it like that. Uh, See, it is again a matter of, it's just like saying, how you grab the ear from one side or another, but things remain same. So if you already have an option, where, you are having the side view is mentioned. So vertical plane, you don't have side view, you have your front view in that. And top view is for horizontal plane, right? So the two pending planes that are there in this particular option is parallel plane or, profile plane. So is there something called parallel plane? Yeah, I mean, see, there could be, but again, in this particular setup, you could have imaginary planes, you could have any planes, like all the, the planes, horizontal and, vertical plane are not parallel to each other, they're perpendicular to each other. Similarly, profile plane and vertical plane and horizontal plane are all perpendicular to each other, right? But there could be multiple parallel planes, right? You could create different horizontal planes at different levels, right? So you can call it that, but, again, two planes that are parallel, they could be called parallel plane. That's how I would go about it. Technically, in geometry, if there is one, that is a matter of question, because every mathematician will obviously go by different terminologies. Ritu Bilani says linear perspective. You want to say something about it, or you want to talk about it? Like, can you elaborate? Same as parallel you are mentioning. Uh, Okay, so you see, parallel planes are obviously, you can obviously have a terminology. I mean, there's nothing wrong with that. Uh, Parallel planes are basically in the planes that are in the 3D space that will never meet. So two vertical planes could be parallel planes, right? At different coordinates, or two horizontal planes could be parallel planes. Two profile planes could be parallel planes, right? So that is how it is. I usually don't like to tinker on with the terminologies, because mathematicians have put in these terminologies with some logic, right? And we are not mathematicians, so I don't like to tinker on with that.